in this lesson we are going to review basically all of the kinds of factoring, and I'm not going to tell you which kind of factoring to do when. You sort of have to figure that out. So there's a process to that. First of all, the first thing you want to do is make sure that you have your equation so that it is set equal to 0. Then, of course, you want to pull out anything you can pull out, factor out the GCF. And then, once you figure that out, you kind of have 3 methods to do. So you can use the difference of squares if you have 2 terms. You're going to undo the FOIL if you have 3 terms, or you're going to factor by grouping if you have 4 terms. And then, of course, once you get it factored, you're going to set each term equal to 0 and solve. So here's our first one. If we follow the steps, it's set equal to 0 already, so that's good. The next step is to factor out a GCF, so you want to pull out anything common, and I can't do that here. And then you're going to look, is there 2 terms, 3 terms, or 4 terms? In this case, there's 3 terms, so I'm going to factor this by undoing the FOIL. And I will start here by listing my factors of x squared, which are just x and x, so that's how that has to be. And then back here, I'll list my factors of 12. So 12 could be 1 and 12, 2 and 6, or 3 and 4. Okay? And again, you're just going to have to try it. If it's a plus right here, it either needs to be plus plus or minus minus, but remember, hint, hint, hint. If that's a plus, then this is going to be plus. Okay? And hopefully you're starting to see some patterns here, and you kind of can be smart about which ones to try. If you try 3 and 4, watch what happens. Okay? I know that x times x gives me x squared, so that's good. I know that positive 3 times positive 4 gives me positive 12, so I'm good. But I need to check my outsides and my insides. So outsides, 4x, insides, 3x. And when I combine 4x plus 3x, I do get 7x like I need to in the middle, so that's good. So this is how it factors. X plus 3 times x plus 4 equals 0. And then, of course, you'll set each parentheses equal to 0 and solve. And you'll get x equals negative 3 as one solution. And set the next one equal to 0 and solve. And you'll get that. All right, here's our next term. Of course, the first thing we need to do is we need to set it equal to 0. So I need to subtract the 60x over. I want you to notice that you already have an x term on the left side that you can combine this one with. So make sure you do that. And so then I have 40x squared. 8x minus 60x would be negative 52x. And then minus 12 equals 0. Okay, so the first step was to set everything equal to 0, which I did. The next step, every time you factor, no matter what it looks like, is you want to see if you can pull anything out that they might have in common. In this case, 40, 52, and 12 are all divisible by 4. Okay, so I can factor a 4 out of there. And then 4 times 10x squared gives me 40x squared. 4 times negative 13x gives me negative 52x. And 4 times negative 3 gives me negative 12. Okay, now, notice that part that's in parentheses is a trinomial. It has 3 terms, and it goes x squared, x, and a constant. So you can actually, because it has 3 terms, factor that like this. Okay, so if I list my factors of the front, 10x squared could be 10x and x, or it could be 5x and 2x. Okay, so the 2 fronts have to make that. The back, negative 3. And by the way, you guys, I forgot to talk about this, but make sure you bring down that 4 that you pulled out. Don't forget about it. Make sure you bring it down, okay? All right, back here, factors to 3. The only way you can get 3 are 1 and 3. Okay, so I'm going to actually lock that right there. 1 and 3. It can't be anything else. If it's minus back here, you need to have 1 of each, so 1 plus and 1 minus. All right, and then I am going to try different ones. So I'll first start off trying 10x and x, okay? I know my fronts are okay, I know my backs are okay, but I need to get that middle negative 13. So if I check it right now, 10x times negative 3 is negative 30x, and 1x times x is x. So that didn't help me. Okay. I could switch the positives and negatives, but that's not going to necessarily help me. So let's switch the 3 and the 1. And let's try this. Outside's negative 10x, inside's positive 3x. Okay? That gives me negative 7x, and I need to have negative 13x in the middle. So that didn't really do it. With the back, it can only be 3 and 1. That's it. Okay, so I have to change the fronts. And instead of trying 10x and x, let's try 5x and 2x. Okay, so here we go. 5x and 2x. Outsides, negative 5x. Insides, positive 6x. If you switch the positives and the negatives, right now I have 1x the way it is. When I combine my like terms, if I switch the positives and the negatives, I would just have negative 1x. So that's not quite doing it. Let's try switching the 5 and the 2. I can't, 3 and the 1 are locked. I can't do anything here. So let's try 2x and 5x. Okay. Outsides, negative 2x. Insides, positive 15x. And when I add negative 2x plus 15x, I get positive 13x, but I need it to be negative 13x. And so the quick fix to that is to switch these positives and negatives. So make this one negative and this one positive. Now if you check your outsides and insides, you'll have negative 15x and positive 2x, which gets you right where you need to be. Okay, so we've got it factored, and now we need to set each part equal to 0. So here we go. If I set 4 equal to 0, there's no x, there's no variable, so there's nothing to solve there because I can't figure out what x can be because there isn't an x. Also, 4 never equals 0, so there we go. Don't need that. Here, 2x minus 3 equals 0, so I will add 3 and divide by 2, and x will be 3 halves. And on the other one, 5x plus 1 equals 0, I will subtract 1 and then divide by 5. And x will be negative 1/5. Alright, here again you're going to get this set equal to 0, and you want to make sure that you have your terms in descending order of the exponents, so you want the biggest exponent listed first. I don't like the biggest exponent to be negative. My biggest exponent right now is negative 10x cubed. I don't like that to be negative, so I'm actually going to add that to both sides, which will move that 10x cubed over, and then at the same time I'm going to subtract 175x so that that gets moved over too. So that's gone, that's gone. Now if you look at what's on your left side, you're going to list these in order from biggest exponent to smallest. So my x cubed term I need that to come first, and then I've got a positive, that's a positive 15x squared right there, and then of course you have your negative 175x. Alright, so if I'm following my process, I have it set equal to 0. The next thing I need to do is figure out what I can pull out of there. So if I look at that, every term has at least an x in there, and then 10, 15, and 175 are also all divisible by 5. So I can pull a 5x out of there. And then 5x times 2x squared gives me 10x cubed. 5x times 3x gives me 15x squared. And 5 times 35, negative 35, gives me negative 175x. Alright, here we go. Bring down your 5x. Don't forget to do that. That's a super duper common mistake, so don't forget to do that. Okay? Then notice what you have left in parentheses is 3 terms. It's a trinomial. So you can factor that by undoing the FOIL like this. Okay, if If it was 2 terms, you would try difference of squares. It's 3 terms, so you're going to do the trinomial. If it's 4 terms, you would try factoring by grouping. So I'm going to list my factors of 2x squared, and we know that 2x squared is 2x times x. Okay, that's the only thing it can be, so I'm just going to go ahead and write it right away. And then in the back, your factors of 35 are 1 and 35, and 5 and 7, and that's all that can be. If it's a minus back here, remember you need to have one of each. And I am going to go ahead and try 5 and 7 first. Okay? So, here we go. Outsides, negative 14x. Insides, 5x. Negative 14 plus 5 does not give me positive 3 that I need in the middle. Okay, let's try it the other way around. Okay. Outsides, negative 10x. Insides, 7x. That gives me negative 3x, but I want it to be positive 3x, so what I need to do is I need to switch those positives and negatives, okay? So I need the 10 to be positive and that to be negative. So that's how that should work. Okay, so now I factored it, and now you need to set each part equal to 0. So, here I'm going to set 5x equals 0, and there is a variable, so I do need to figure out what x has to be to make that be 0. You can't just cross it off, so I will divide by 5, but 0 divided by anything is still 0. Okay, this parentheses, 2x minus 7 equals 0, I will add 7, and then divide by 2, and x will be 7 halves. And then this parentheses, x plus 5 equals 0, I will subtract 5, and x will be negative 5. Alright, this one, again, is not set equal to 0, so I want to move everything so that it is. You want to list these terms in order of descending exponents, so the biggest exponent needs to come first. So I have 3a cubed minus 3a set equal to 0. So I've got it set equal to 0. The next step is to see what you can factor out. So in this case, I can factor a 3 out, and I can factor an a out. Okay? So I need to figure out 3a times what is a squared, and 3a times a squared gives me 3a cubed. 3a times negative 1 gives me negative 3a. Okay, so now you're going to look. And it has 2 terms in parentheses. And when it has 2 terms, you want to check to see that it's a difference of squares. And remember, difference of squares means you have a quantity that's squared with a minus sign in between, and then another quantity that's squared. So a times a is a squared. That means it's a quantity squared. And 1 times 1 is 1. People don't realize that 1 is a perfect square, but 1 times 1 is 1. So 1 is actually 1 squared, quantity squared, and I do have the minus sign in between. So bring down the 3a, and then this part here that has 2 terms can be factored as a difference of squares. Remember, this times this is your front squared. So a times a makes a squared. And your 2 backs have to make 1. And the only way to get 1 is 1 times 1. I do have this minus in the middle, so I need 1 plus and 1 minus. And now if you check your outsides and your insides and you FOIL that back out, you should be good to go. Okay? And then set each part equal to 0. So 3a equals 0. I do have a variable here, so I do need to figure out what does a have to be so that it turns into 0. So of course you'll divide by 3. 0 divided by anything is 0. Okay? This parentheses, a plus 1 equals 0. Subtract 1. And this parentheses, a minus 1 equals 0. Add 1 to both sides. And you'll get a equals 1. All right, this one already is set equal to 0, so the first step is done. It is not listed in descending order, but that's okay. We're going to leave it as it is. You'll see why in a minute. It does need to be factored, so I do need to figure out what I need to pull out of there to make that as simplified as possible. So I need to figure out what I am going to factor out. And so 32 and 162 are both divisible by 2. And so when you factor 32 divided by 2, when you factor that 2 out, 2 times 16 is 32, and then 2 times 84, or 81, I'm sorry, is 162. So 2 times 81k squared gives me that, okay? Again, don't forget to bring down your 2, okay? And now you want to see if what you have left happens to be, can I factor it as a trinomial? There's not 3 terms to it, so I can't do that. It only has 2 terms, so that's a big hint that you hopefully can do difference of squares. And remember, difference of squares needs to have a number that's been squared. Well, 16 is 4 squared. It needs to have a minus sign in the middle, which it does. And this needs to be a quantity squared as well. So 81 is 9 times 9. And k squared is k times k. So it is a quantity that's been squared. When that happens, remember, you can factor this as difference of squares. So 4 times 4 makes the 16, and 9k times 9k makes the 81k. Make sure you list them in the same position. Like the 4's have to be in front because the 16's in front, and the 9k's have to be in back because the 81k squared is in back. And then remember, when you have that minus sign in between, that you need 1 plus and 1 minus. So it's factored, and now I want to set each part equal to 0. So if I look at this part, there's no variable in there. I don't have a k in there, so I don't have to figure out what k has to be. And if you think about 2 equals 0, 2 never equals 0. Okay? Over here, 4 plus 9k equals 0. I will subtract 4. And I will have 9k equals negative 4, divide by 9, and k will be negative 4/9. And then over here, 4 minus 9k equals 0, I will subtract 4, and divide by negative 9. And remember that a negative divided by a negative becomes a positive. All right, this one does have 4 terms to it, and some of you will realize when you do this that I can actually take this and combine your like terms to get 12x and do it that way. And if you realize that and you want to do it that way, that's fabulous. I want to practice factoring by grouping. So I am going to recognize that this has 4 terms, and I'm going to take these first 2 terms right here, and I'm going to factor out what I can. So 6x and negative 9 are both divisible by 3. So 3 times 2x makes 6x, and 3 times negative 3 makes 9. Then I'm going to take these terms right here, and I'm going to factor out what I can. I don't like that first term to be negative, so I'm going to factor out a negative. So 4 and 6 are both divisible by 2, but I'll factor out a negative so that it becomes positive. And then x squared and x, they both at least have 1x to them. So negative 2x times positive 2x gives me negative 4x squared. Negative 2x times positive 3 gives me 6x. Sorry, not positive 3, negative 3. And negative times a negative makes a positive. Okay? And then, of course, recognize that each, the green and the red, have a 2x minus 3 in them. So I will factor the 2x minus 3 out. When I do that, I have a 3 left in the red. And when I factor it out of the green, I have negative 2x left. And now you're at the point where you can set each parentheses equal to 0 and go ahead and solve it. Oops, and by the way, guess what I forgot? Oh no, I didn't. Okay. Set each parentheses equal to 0. So 2x minus 3 equals 0. I'll go ahead and solve that by adding 3. And then divide by 2, of course. And x will be 3 halves. on the other one. I will subtract 3. Divide by -2. And again, I get 3 halves. And sometimes that happens. The other way to do what you could say is you could say x equals 3 halves, and then you could say double root. You get the same answer twice, and you want to get smart. You'll see why and where this happens later, but this does happen occasionally. And if you get the same answer twice, like you did here, if you want to, you can just list it once and then write double root by it if you want. You don't have to do that part, but if you want to get ahead of the game, you can. All right, and our last one over here, okay? I need to set this equal to 0 first, so I have x squared plus 16 over 49, and I probably should show you how I got that, huh? I need to set this equal to 0, so I'm going to add 1649s to both sides. Okay? So now my next question is to see if I can factor anything out, and I actually can't factor anything out of here. There's nothing I can do, so I can't do that. But I can check to see if this is difference of squares. It only has 2 terms to it, so it's not going to be a trinomial. There's not 4 terms, so I'm not going to factor it by grouping, but it does have 2 terms, which leads people to believe that it's a difference of squares, okay? Remember, difference of squares has to have a quantity squared with a minus sign in between, and then another quantity squared. This one has a plus sign in between, so this is actually not, I'm going to say this, no solution by factoring. Make sure you write that by factoring piece on there, because you will learn later that there really is a solution to this. It is ugly and it is not pretty, but there is a solution. We just can't find it by factoring. Okay, we have to have other tools which we aren't going to learn about in this lesson right now. So, oops, that should be your answer, but no solution by factoring is your answer. Super common mistake that people will make on this one is they'll go y and y. Don't freak out about a fraction. 16 is 4 squared and 49 is 7 squared. So if you think about the top and the bottom separately, this is just 4 sevenths and 4 sevenths. And then people go, oh, this is a difference of squares. So I'll go 1 plus, 1 minus, and life's good. Okay? That does give me y squared plus 0y. But here's the problem. It has to be positive 1649s. So my outsides and my insides right now do give me the 0y in the middle, but it doesn't give me positive 1649s. When I check my 2 backs, I have 4 sevenths times negative 4 sevenths, which gives me negative 1649s, not positive 1649s. And that's why, remember, your solution to this one is no solution by factoring should be your answer. Okay? Now, this is not on your notes, but I just want to show you this really quick. If I had something like this, let's see. Okay, if I had something like this, and I factored a 3 out, and if I factor 3 out, then I'm going to have k squared plus 3k minus 12. Okay? And sometimes you're going to get this far and you're going to go, okay, I can bring down the 3, and then I can undo the FOIL here, and I know that my front has to be k times k. My back has to be 12, so I'm going to try 2 and 6, and that gives me 6k on the outside, 2k on the inside, which is just 4k. That doesn't work. If I try 1 and 12, that gives me 11k in the middle. That doesn't work. If I try 3 and 4, 1 plus 1 minus, that gives me negative k, because my outside's negative 4k, my inside's positive 3k. That gives me negative 1k in the middle. So I actually can't factor this. Sometimes, on a rare occasion, all you're going to be able to do is get this far right here. Okay? That's all you can do. I want you to get that far though, and then beyond that, it doesn't factor. Okay? But get that far and circle that answer for me.